Good morning, everyone. So I hope all of you are ready, and let's start. So the last time we solved those homework questions, right? And before that, we talked about how a vector can be divided or split into components, right? Okay. All right. Right. Now, I hope you can see the screen, right? So this is the list of important points that we had the last time. So let's just start from there, right? Okay. So we learned the parallelogram law of addition of vectors, right? We learned that if there is a vector which has magnitude 1, we call it a unit vector. Okay, no scribbling on the board. Yeah, okay, thank you. Right. So if there is a vector with magnitude 1, then we call it unit vector, right? The symbol of unit vector is like this. It's a cap at its top. All right. Okay. And then this number 4 is a important relation of a unit vector, right? That vector A is equal to magnitude of vector A into that unit vector A, right? Unit vector A, which is in the direction of vector A, right? So again, this equation tells you that any vector can be written in two parts. One, its magnitude, and the second one, its direction, right? So the unit vector indicates the direction, right? That's what we studied, right? Okay. And then we talked about special unit vectors, right? Two unit vectors, right? The two unit vectors are I caret and j caret, right? I caret is in the direction of positive x axis, and j caret is in the direction of positive y axis, right? Okay, so see, I'm making you revise all this because it's really important, all of it, right? And then here I've given you one example, so hopefully you understood how we got this finally, right? This is where we stopped. Yeah, it's also called a cap, right? Okay, so I hope all of you have at least understood the basic of how we are getting this here, right? This a vector, it has two components, right? This is one horizontal and one vertical, right? So if you're going to do it, if you're going to do it in, if you're going to write it in component form, then 10 is along x-axis or in the positive x direction, so 10 I caret, and 40 is along the positive y direction, so that's why 40 j caret. So this is actually true in general. In fact, we are going to practice some questions like this today, right? Okay, let's start. All right, so I remember the last time there were questions, what about the negative x and negative y, right? So I will start with an example that will help you with those concerns, right? So let's say that this is some coordinate system, right? So positive x, positive y, negative x and negative y, right? Okay, clear? So then suppose we draw, okay, right now forget about, lots of physics, just think of this simple idea. Suppose we draw one vector, let's say from this point A to suppose this point B here, right? And let's say the point A has coordinates 3 comma 4 meter, right? And let's say this point B has coordinates, let's say, minus 2 comma 1 meter, right? Okay, so if it is like this, and suppose we draw a vector from A to B. So why do we need to draw a vector from A to B? You might say that some particle, maybe some ant, moves here and there, and finally goes to that point, right? So if you want to find the displacement vector, right? If you want to find the displacement, remember displacement itself is a vector, right? So if you want to find the displacement, then that's going to be an arrow, a vector like this, correct? I hope you have understood that so far, right? Okay, so if you would consider, only the maths right now, okay, I want to write this in form of I caret and j caret. All right, that's what I want to do. That's what all of you should learn. This is a very important way, a very important notation. Okay, so if we want to write this vector in form of I caret and j caret, how would we write it? So to do that, remember, all of you, remember this. To do that, you should draw the vector. Let's say this is that delta r vector. Okay, let's say this is that delta r vector. Okay, I've just drawn it over here again. We should trap it compulsorily. We should trap it in a rectangle. Trap it, that is like this. Okay, did you understand? So basically, what I'm doing is how much does this have on the horizontal? Remember, the horizontal will go with I caret, correct? And the vertical will go with j caret. Do you understand this? Yes or no? Yes, Vedant, you are right. Every vector can be written in such two forms. Okay. So now, do you agree? Do you agree that the horizontal one? Do you agree that the horizontal one is 5 meter in length? This horizontal side is 5 meter. Now why is it so? Think about it. From here to here is 3 meter, right? That's called x coordinate. And from here to here is 2 meter, right? So total horizontal is 5. अरे 4 plus 1 नहीं सौरभ, 4 plus 1 5 is different. If you say this is 4 plus 1, I'll say wrong. Okay, 4 plus 1 5, wrong. This is 3 plus 2 5. Okay, now Now what about vertical? What about vertical? What do you think is this side of the rectangle? It's coming from 4 to 1. I hope all of you realize that when we draw points, when we put points, this is 4 meter, but this is only 1 meter, correct? Right? I hope this is clear. Okay, if we draw a vector from this point to this point, we're getting 5 meter and 3 meter. So, you know, if you look at this carefully, no, Vedant, don't try to rush. Okay? Now, if you look at this vector carefully, right? Do you realize that this vector, the displacement vector, is actually going here in this direction? So it will, if I want to make it in form of two components, if I want to make it in form of two components, the horizontal component shall be made like this is the horizontal one, and the vertical component shall be made like this. Do you agree? I'm using triangle law. I'm using triangle law of addition. Clear? Sir, explain. What should I explain? Priyansh. Okay. This is just one final chance for people who did not understand. Suppose you have got 2 points A and B, and if you join them by a line, then do you realize that you can make a triangle like this? Okay, if you take that triangle further, this will become a rectangle, correct? So I hope all of you realize that this width is actually equal to this minus this. Yes or no? Right? So for example, I took here this to be 4, no, sorry, 3 and 4, right? And this is minus 1 comma, sorry, minus 2 comma 1. So if I will subtract, then I'll get 3 minus minus 2, so that is 5. And like that, I'll get this as 4 minus 1, right? I hope all of you realize that. So that's going to be 3. Okay, so y caret ક્યાંય છે જ નહીં. Where did you see y caret? Okay, so we have got this as a vertical one and this as horizontal one, right? We've got this as vertical and this as horizontal. So do you realize that the vertical is actually going down? This vertical arrow vector is actually going down, right? So what that means is when we write it for j caret, we should not write 3 meter, we should write minus 3. Who understood this? Yes or no? Why are we writing minus 3? Because of this. Don't raise your hand, people. Say yes or no. Raising hand has hundreds of meaning. What should I get? Okay. Yeah, no problem, Ayush. No problem. You did it by mistake, but some people sometimes they do that. Okay. All right. Dharmi, please don't say, please explain that. What should I explain? Because there's no way I'll know what is meaning of that here, right? You cannot point it. Can you please say what should I explain again? So just like this, if you do it for horizontal, Dharmi, I'm waiting for your question. Okay. Just like this, if you, okay, right, fine. Let's just go through this one more time, right? Let's go through this one more time. Okay. This time, forget. I really think we should go back to basics, right? Suppose Suppose I would draw a vector that is 3 units in length. Okay, let's call this a vector. Then first of all, do you all understand that this a vector should be called 3 I caret? Yes or no? Okay, very good. Now, suppose instead of this, there is a vector b which is like this, okay, but that is 4 units in length. What do you think we should write for it? What do you think we should write for it? Yes, Sanju, what is it? Yes, so this is going to be minus 4 I caret. Minus 4 I caret, right? I hope everyone understands why it is minus and why it is I caret. Okay, because listen to this. I caret means unit vector, one length, one magnitude on right side, on positive x side. Okay, I caret means one magnitude on positive x side, but this vector is 4. So actually I'll have to draw 4I carets but in opposite direction. I hope you understand what I'm saying, right? So this is minus I caret, this is minus I caret, this is minus I caret, and this is minus I caret. So total minus 4I caret. Okay. Again, the minus sign is indicating the opposite direction. Okay. Now, yes, Vedant, what you said is okay. Suppose there was a vector C like this, right, which would be 3 units in length. What would you write for C vector? Suppose there was a vector C like this, what would you write for for this C vector? Very good. I think most people have now understood, right? So I think I can jump back to what I was explaining. The basics are clear, so I'm happy about that. જેના basics clear એનું બધું કામ થઈ જ જાય, બરાબર ને? જેમ કે આ ટ્રાયંગલમાં કેવી રીતે લેન્થ ફાઇન્ડ કરાય એ ન આવડે તો તકલીફ પડે છે. સી એવરીવન, I think all of you do realize that આ length 3 કેવી રીતે આવે અને આ length 5 કેવી રીતે આવે, that is very basic, isn't it? Okay, so we have drawn a vector like this something. Okay, અહીંયા point મૂક્યા હતા. What was this point? 3, 4, right? And this point B is minus 2, 1. I would draw કર્યું હતું. So I'm saying that if you would trap it in a rectangle like this, okay, right, and then you measure this is 1 meter or 1, okay, meter છે ભલે રહ્યું, અત્યારે મારે બધે meter નથી લખવું. This is 4. So I hope everyone realizes that this part has to be 3. It સમજાવ્યું હતું. I'm just repeating it, okay, for last time for anyone who might not have understood, right? And similarly, this distance is going to be 2, this distance is going to be 3, and this distance is 2 because x coordinate is 2 and here x coordinate is 3, right? Okay, આટલું તો આવડું જ જોઈએ, x coordinate y coordinate. So finally this whole side is 5. But the point is, look at this vector. If I will divide this vector, if I will split this vector into horizontal and vertical components, suppose r vector delta r vector, okay, so let's think of two components, one going down like this, niche jai ne, I don't think I can draw it up. I hope you understand, we are talking about rectangular components. I hope everyone has been reading the theory, right? You cannot draw it up, it's impossible. So I must divide this, I must take components like this. This is one, suppose we call it a vector, right? Acha a nahi, chalo c vector, right? And let's take one more vector, d vector, like this, right? I hope everyone is seeing it, and finally everyone understands that we get this relation, yes or no, by triangle law. Okay, so c vector is clearly 3 in length, right? C vector is 3 in length, but it is not in positive direction, right? It's not in positive y direction, it's actually going down. That means it is in negative y direction. So mare -3 j caret લખવું જોઈએ. Clear? હવે આનાથી easy મને સમજાવતા નથી આવડતું. So this is your last chance, everyone. Okay, then if you look at d vector, look at d vector, what do you think we should write for d vector? What do you think we should write for d vector? Raj, you are still getting it wrong. Gracie, wrong. It's a vector. Answer number no આવી શકે. No, Dikshita. Joy, it's not carrot. It's a carrot. The correct is -5 I caret. The correct is -5 I caret. Clear? I hope this minus sign is clear. Okay, but see, every time, listen to this, every time we don't like to do all this. આટલું બધું draw કોણ કરે દર વખતે? You should learn to do it without spending any time at all. Okay, you should be able to do it immediately. Okay, let's try one more. Come on, let's try one more. Okay, yes, j, it was j caret. Everyone just keep simple idea in mind. આ ડાયાગ્રામ માઇન્ડમાં હોવો જોઈએ, સપનામાં એ દેખાવો જોઈએ. Is that clear? And equivalent this, right? That x, on x axis you have I caret and on y axis you have j caret. I hope this is clear. Asu x2 minus x1 upon y2 minus y1. Raj, what are you saying? Why did you write that? Okay, you are putting comma. Yes, there is a comma, correct. That's how you can do it, right? Okay, so try this now. Suppose we draw a vector from, let's say, this point P, which is the fourth quadrant, so 5 comma -3 to maybe somewhere here, let's say Q, so that this is minus 1 comma 7. Yeah, come on, can you write what is PQ vector in form of components? So writing in form of components means writing its components means writing in form of I caret and J caret. Okay, do it, come on. PQ vector. Yes, Dev. See everyone, I want the correct answer in one go. મને આવો કંઈક answer જોયો. 7 I caret plus 16 J caret, something like this. Okay, I want this final answer from you, everyone. I want this kind of final answer from you. Do not write anything else. I will not consider that answer. Okay, I want comma no ave vacche, Raj. There is no comma anywhere. If you write I caret J caret, there is no comma anywhere. Okay. No, it is wrong. Raj, your answer is wrong. Rahul, it's wrong. વચ્ચે પ્લસ માઇનસ કંઈક આવું જોઈએ. પ્લસ માઇનસ આવું લખો. પીપલ રાઇટ ઇટ લાઈક ધીસ પ્લીઝ. આ કેવું વ્યવસ્થિત લખ્યું છે? સમથિંગ પ્લસ સમથિંગ, something minus something. Okay, something like that. Yes. Still, most answers are wrong. Some are correct. I'm not saying all are wrong, but I can see a lot of wrong answers. Ami, where is J caret? Okay. Well, people, first of all, I'll hope that you all have drawn a diagram. Okay, from here to here, did you draw an arrow? All right, now see, let's keep it simple. Look at this vector. Do you agree that this vector is going upwards and this vector is going leftwards? Agreed? Yes or no? Upwards and leftwards. So that will help you so much, right? That will help you so much. Aren't we taking from Q to P? No, we are taking from P to Q. Look at this. What is meaning? What is meaning of this? We are taking from P to Q, right? I hope everyone understood that. Okay. So now trap it in a rectangle like I said. Okay, like this. Okay, not a very good drawing, but I'm sure you understand. So I hope you all realize that this is going to be 6, right? And this is going to be 10, right? This is going to be 6 and 10. But see, 6 in horizontal, so 6 I caret, but it is going leftwards. So leftwards is of course negative x, so minus 6 I caret. Did you understand my technique? No, Ayush, it is wrong. Did you understand my technique? I repeat, 6 in horizontal, so I wrote 6 I caret, but then it's going leftwards. Left is negative x, so minus 6 I caret. Okay, then here 10. All right, so this is 10 going upwards, so plus 10 J caret. Clear? So this is your final answer. So this is your final answer. Okay, Yeah, you were right, Rahul. No what ifs, Falak. The method applies every time. Okay, so no, there is no scope of what ifs, right? This method is true always. Okay, I'm of course giving more examples, so that will help everyone. Okay, so Raj here pointed out that we can also do it by this form. Listen to this carefully. Raj pointed out that we can also do it by taking x2 minus x1 I caret and y2 minus y1 j caret, and he is right. Okay, I was actually going to save this explanation for later, but anyways, he mentioned it, so I thought you all might find it easier, right? Because if it comes from one of you, you are always going to find it easy, right? He said that we can do it like this also, and absolutely right, you can do it like this. But yes, you should understand which is initial, which is final, right? Which is first, which is second. Otherwise, you'll get the wrong answer, right? So here x2 means final, so final is q. I hope all of you realize that. And initial is p. Look at the arrow. Arrow goes from here to there, right? So x2 is minus 1, x1 is 5, okay, and y2 is 7, and y1 is minus 3. I hope you understood this. So we get minus 6 I caret and plus 10 j caret, right? Yes, very good, Vedant. Good observation, right? You learned something very important. All right. So this is another method, right? We are actually going to discuss this method in full detail sometime later, right? Okay. Let's try one more. One final. Okay, and this I'm not going to explain at all. I'll just tell you the answer. હવે નો આવડ્યું તો નો આવડ્યું, કઈ વાંધો નહીં. ફિઝિક્સ નો ભણતા આગળ. બરાબર? Okay. All right. Find this vector. You have 30 seconds. Time is ticking. Hurry up. મને પરફેક્ટ આન્સર જોઈએ, પ્લસ માઇનસ આઈ કેરેટ જે કંઈ હોય. આઈ વોન્ટ એવરીથિંગ પરફેક્ટ. જેવી રીતે તમે એક્ઝામમાં લખી શકો એવો આન્સર જોઈએ મને. ઓકે, નો હાફ્સ, નો ઇફ બટ્સ, નથિંગ, એક્ઝેક્ટ જોઈએ. વેરી ગુડ રાજ, વેલ ડન વેદાંત. Yes, Sahil, well done. No sort of slight mistake. Okay, we are getting lots of correct answers. Divya, Dikshita, Jaikit, Priyansh, Malik, Rehan Khan, Tamanna, Dia, Ankita. Yes, very good. Only few answers are wrong. Few answers are wrong. Okay, now we are getting lots of wrong answers. Okay, Vandan, no, it's not correct. Nemi, it's right. Rahul, it's right. Gracie, all right. Okay, the correct answer is 5 I caret plus 7 j caret. Right? Correct answer is 5 I caret plus 7 j caret. Okay. You know what? it's an arrow like this, right? Okay, so now I don't know about you, but I can actually, for me, these plus minus signs are not at all a problem. Some of you are struggling with it, right? Some of you are struggling with it. So for the benefit of everyone, I'll teach you one more way to do it. See, I want you all to get it very naturally, right? તમને એવું થવું જ ન જોઈએ કે આમાં કંઈ આપણે શીખા, એવું જ લાગવું જોઈએ કે આ તો આપણે નાના હતા ત્યારથી જ આવડે છે. એટલું નેચરલ થઈ જવું જોઈએ તમારા માટે. Okay, that is required. So I'm saying that if you draw an arrow like this, if you draw an arrow like this, do you see that this arrow is actually pointing? This arrow is actually pointing. Okay, pointing is very important. Pointing towards first quadrant. Yes or no? હું એમ નથી કહેતો બધાને આવડી જશે, right? Some of you will not get it, no problem. Yes, upward and right side. That's why towards first quadrant, upwards and right side. So I hope you all remember that you have been taught in perhaps 9th or 10th that in the first quadrant both are positive. So both એટલે શું હતું ત્યારે coordinates હતા. I hope you all remember that, right? But now they are not coordinates, they are components. When we talk about vectors, for vectors they are components, right? Not coordinates. Vector na coordinates no hoy, point na coordinates hoy. You take a point, this point has coordinates, but you take a vector, this vector has components, horizontal, vertical, like that. Okay, so that's why both are positive. See, no confusion, isn't it? Just like that, if you would revisit this one, have a look. This is pointing upward and left, correct? That means in the second quadrant. Agreed? This is pointing in the second quadrant. Clear? So that's why in second quadrant x is negative, y is positive. That's what you have been taught. Have a look here. Have a look at this. X component negative, y component positive. So I hope your intuition has developed, your ideas have become more natural, right? Kharakhar, I don't know about you, but frankly I find this rectangle method easiest. Okay, I find the rectangle method very easy. Yes, that's right, Vedant. You are doing it exactly like I do every time, Vedant. See, I told you, for some people vectors is natural, and I said you are one of those, just like me, right? Okay, so it's not a coincidence that both of us are finding all this very very simple. મને તો એવું લાગે છે કે આ તો 11th સ્ટાન્ડર્ડમાં શીખવાડવાની જરૂર નથી, આ તો કદાચ 9th માં આવડી જાય. I don't think everyone will agree. I'm just saying so, right? Okay, fine. So that's it about components, right? Just before we wind up this topic, I want you to do one more thing here, right? Can you find what we should write for this? Come on, in this same diagram. Okay, you see the diagram? Can you write for this, everyone? Can you write for this? People, I'm waiting. Can you write be a vector? No, Gracie, think about it carefully. Okay, still some of you are doing it wrong. I'm not really very happy, right? I I don't know. I'm not so sure. What method are you using? Come on. I want to know. Okay, this is a vote. Are you using method number 1 that I taught you, that is rectangle method, or are you using the method that Raj suggested, that one, x2 minus x1, like that? Come on, vote. What are you using? Method 1 or method 2? Method 1 or method 2? Vote. Method 1 or method 2? अरे quadrant method नहीं, 1 2 बोलो ना खाली. हाँ, rectangle and quadrant, right? Both are together only. Both are same, right? So those who are using method 2, I have to warn you, subtraction ma mistake no karta. I think many of you are making mistake in subtraction. Many of you are making mistake in subtraction, I think. Right? You have to be careful. Dhruv, you made a mistake. Right? You have to be careful. B to A. Mouse. Is that clear? So this is 1 and this is 2. Okay. I hope you realize that. Final, initial. So this is final, this is initial. Final minus initial. So this should give you -5 minus 0 I caret. This is for method 2 people. Okay. And plus 0 minus 7 J caret. મને તો બધી રીતે આવડે છે. તમારે એક રીતે તો શીખવું જ પડશે. Is that clear? Hard, I didn't notice your answer. I'm so sorry. There were many people answering it. So, okay, all right. Very good, Ayush. I personally think that if you draw this arrow, if you draw this arrow, then it's quite clear. It's quite clear that this is 5 and this is 7. અને આ જાય છે કઈ બાજુ? આમ, that is downward and left side. So clearly -5 I caret -7 J caret. આ બધું માઇન્ડમાં આમ ફ્રેક્શન ઓફ સેકન્ડમાં ધડાધડ થઈ જાય, કોઈને ખબર ન પડે. I hope you understand what I'm saying, right? There is no scope of mistake, in my opinion, in method 1. It is very natural, at least to me, right? Okay, fine. So I think that's enough of this topic. All right. I will definitely give you more questions. I will definitely give you more questions in homework, right? Right now, let's go to the next thing. Yes, in homework. Okay. So let's write everything properly now. Okay, we will use proper symbols. How to write all this with proper symbols? Look at what I'm drawing carefully, and please you also draw it. So let's say that this is some coordinate system. So plus x plus y minus x minus y. Okay, and let's say that there is a vector. It may be from origin, may not be from origin. Ideas remain same. Okay, so let's say this is a vector, A vector. So what I'm going to do is I'm going to divide this or split this into components. So do you agree that one horizontal component should go like this, correct? That is called AX. Now I'm giving it name. What am I calling this? AX vector. Clear? Why AX? Because that AX vector is along or in the same line, parallel to X axis. Do you see, everyone? I hope you are seeing it. Basically, horizontal matlab X. That's what we are doing here, right? Horizontal means X. That's what we are using, right? Okay, now let's draw one more. See, I'm drawing it from the head of the first. So basically I'm using triangle method of addition. Did you understand this? There is a good right angle here. Is this clear? Okay. So then do you understand this equation that I'm going to write here? Say yes or no when I'm done. Say yes or no. Okay. Right. Now think about this. Think about this. Do you realize that every vector, so ax vector is a vector. I can write it in form of magnitude and direction. Again, this is magnitude and this is unit vector, so it is showing direction, correct? Is this clear, all of you? And similarly, I should be writing ay vector equal to ay j caret. Again, this is magnitude and this is unit vector, so that is direction, right? That is indicating direction. Clear? So finally I should write this whole thing as, right? Clear? So this is a very important relation. Okay, this is a very important relation, everyone, right? This is telling you about its two components. I repeat, this relation or this one also, right? But this is not that useful, right? We use this form very often, right? Most often used, right? Okay, so here what we are having is this is the x component. See, why am I calling x component? Because it is along the x axis or parallel to x axis. Have a look at this. It's parallel to x axis. So what is this called? This is called x component, right? And similarly, this green one, ay vector, is parallel to y axis. So we call it y component. Clear? Okay. Right? So this is a very important relation. Okay. Now, if you realize, yes, you are right, Veda. If you realize, we have been writing it like this only, correct? Let's see. Look at this. Haven't we been writing it like that? Right? I hope you are seeing it. So it's just that, suppose, like, let's say this was 3 and this was 4, then this whole thing would become a vector equal to 3i caret plus 4j caret. Easy, right? So actually, so this is the standard form of writing a vector. Okay, this is called the standard form of the vector, where we write the vector in form of its components, right? Which components? X component and y component, because there are only two, x and y, right now. Okay. Now, from here on, it is important to understand that we could also use the parallelogram law to get the same addition. I hope you remember that. If I'll draw AY over here, right? And similarly, if I draw AX from here, do you see this is also parallelogram law? I hope that makes sense, right? See, this is that rectangle which I was drawing, if you understand. I hope you realize why we were making a rectangle. Okay. All right. Now, let's talk about an interesting thing. Earlier, if you remember, we said that to write a vector, you need a magnitude and you need a direction. And direction is typically indicated by angle. Yes? Right? We need a magnitude, we need a direction, and direction is indicated by an angle. Right? So many punctual people have left the class. Okay. What happens? They are hyper punctual. આવે 5 મિનિટ મોડા ને જાય 5 મિનિટ વહેલા. મોડું ન થવું જોઈએ. Okay. So now if you want to find out about angle, હવે આ બધું angle એમને કોણ સમજાવશે? અને કદાચ કાં ટ્યુશનમાં જતા તો ટ્યુશનમાં માંડ સમજાણું હોય, પછી હવે અહીંયા બીજી વાર સમજી લીધો તો સારું પડે. તો કઈ વાંધો નહીં, ચલો. So suppose this angle is theta. Suppose this angle is theta, right? So do you see that we can make a right angle triangle, and if I use tan theta, in that diagram, okay, આ બધું ચાલુ જ છે, ઇમ્પોર્ટન્ટ ડિસ્કશન. દેર ઇઝ નો બ્રેક. આખો ચેપ્ટર જ ઇમ્પોર્ટન્ટ છે, પહેલે જ છેલ્લે સુધી. tan theta, what do you think is tan theta? આવડે ને બધાને ડેફિનેશન? tan theta equal to, ફટાફટ બોલો જલ્દી, hurry up, come on everyone, what is tan theta equal to? What is tan theta equal to? Okay, I've got variety of answers, right? Okay, see, there's just a little advice that I want to give all of you. Some of you are saying that tan theta is equal to opposite upon adjacent. Some of you are saying that it is equal to perpendicular upon base, right? Okay, and some of you have said it is equal to sine upon cos. Okay, so while all are correct, right, I would advise people using this form to shift to this form. Okay, this is my advice to all of you who said perpendicular upon base. I advise you that instead of saying perpendicular upon base, you learn this. Okay, this is going to help you. All right, this is going to help you. Okay, now some of you said sine upon cos. It is correct, but it is of no use here, right? In this question or in this particular situation, it's of no use here, so we will not use it, right? Okay, વેદાંત તો હજી perpendicular upon base કે હું ના પાડું છું, right? People, please learn opposite, adjacent and hypotenuse. Okay, that helps a lot. So tan theta is opposite upon adjacent, right? So what is opposite, what is adjacent? Let's see. Look at theta. Its opposite is AY and adjacent is AX, right? I hope you understood that. Opposite is AY, adjacent is AX. So that's why this is equal to AY upon AX. So that's an important relation. If you want to find what is that angle, if you want to find what is the angle, then you can use tan theta equal to ay upon ax, right? What is theta here? Theta is angle between vector and positive x direction. Okay, so this is once again an important relation. Okay, tan theta is ay upon ax, where theta is angle between vector and positive x direction. Have a look at diagram. બધું diagram માંથી થાય, આ ગોખવાની જરૂર નથી. Trigonometry તો આવડે ને એટલું, opposite and adjacent, right? So tan theta is opposite upon adjacent, right? Clear? Okay, right? I know the time is up. I'll just take 1 or 2 more minutes. Angle no topic ચાલુ થયો છે તો પૂરું કરી નાખે angle સુધી, right? So suppose now you try to think of cos theta. If you try to think of cos theta, right? What do you think is cos theta going to be? Can you tell me that? Cos theta. Everyone. Cos theta. Yes, it's going to be adjacent upon hypotenuse. So if we put the values here, we will get cos theta is equal to ax upon a, right? Again, this is adjacent and this is hypotenuse. Clear? So cos theta is equal to adjacent upon hypotenuse, right? Okay, so based on that, do you understand? Right? Okay, and just like that, I'm going to say this. Okay, but I will say prove this yourselves. Okay, I'm not going to prove it. Okay, I'm not going to prove it. You prove it yourself. Clear? On your own, in your notebook, right? Very easy to do, very easy to do. Okay, so that's it. We will stop over here. Okay, right? So goodbye. This is the end of this very important lecture. There is one more trick to find components. Okay, I'd like to know what that trick is, right? Just to improve or check my knowledge. Yes, yes, Gracie, that is right. Ay upon a is right. Yes. No, there is no behind the lecture knowledge, right? Of course, Ayush, what you are saying is right. And I don't know whether you noticed it, but I've written it somewhere today. Let me just check it. Have a look at this. Ayush, do you want to say anything about this? Have a look. Look at this diagram. Right? But yes, it has come to you naturally. I can see that. Okay. 52 people are still here hanging around. શું હવે ચા નાસ્તો કરાવું પછી જશો? Yeah, bye everyone. Goodbye.